are listening to Neurosalience, the OHBM podcast.
Welcome to the Organization for Human Brain Mapping Neurosalience podcast. I'm your host for today, Kevin Cetek. But wait a second, where's Peter Bandettini? Don't worry, Peter is still here on the podcast today, but this time as a guest. Over the 39 episodes of this podcast, Dr. Bandettini has guided interesting conversations with brain scientists of all types about the latest developments, controversies, findings, and challenges in the field of brain mapping. Of course, Dr. Bandettini is an impressive and fascinating scientist in his own right, so we on the Neurosalience production team thought it was time to turn things around and shine the spotlight on Peter. So, who is Peter Bandettini? At the National Institute of Mental Health, Dr. Bandettini is chief of the section on functional imaging methods, as well as director of the Functional Magnetic Resonance Imaging Core Facility and director of the Center for Multimodal Neuroimaging. Peter received a bachelor's degree in physics from Marquette University and his Ph.D. from the Medical College of Wisconsin, where his dissertation was on magnetic resonance imaging of human brain activation using endogenous susceptibility contrast. So, basically, functional MRI. Peter then did postdoctoral training at the Massachusetts General Hospital Nuclear Magnetic Resonance Center and Harvard Medical School before returning to the Medical College of Wisconsin as assistant professor. In 1999, Dr. Bandettini moved to the National Institute of Mental Health, where he's been ever since. Peter's contributions to science cannot be overstated. As of this recording, his research has been cited almost 44,000 times, with 5 of his papers having over 2,000 citations. 10 of his papers have over 1,000 citations, and 20 have over 500 citations. Dr. Bandettini has also written the book on functional MRI, published by MIT Press, entitled, appropriately, fMRI. Peter has been highly involved in the Organization for Human Brain Mapping since, essentially, the beginning, including serving as president, as well as program chair, and he currently sits on the Scientific Advisory Board for the organization. Peter is also a fellow of the International Society for Magnetic Resonance in Medicine, where he was awarded the ISMRM Gold Medal in 2020, and he was previously the editor-in-chief of the journal Neuroimage, along with serving as associate editor for that journal and many others. Through all of this, Dr. Bandettini has advised numerous grad students and postdocs, some of whom you'll hear about in today's episode. We'll hear about Peter's approach to mentorship, to science in general, and to science communication, as well as much, much more. We hope that you've enjoyed the podcast so far, and we really hope that you enjoy today's very special episode. All right, Peter Bandettini, welcome to the OHBM Neurosalience podcast. I feel like you've been here before.
Yeah, I've been here before, but never in this context, being the recipient of the questions, but look forward to it.
Yeah, and I mean, listeners will be very familiar with all of your interviews and great discussions over the past year or so, about 40 episodes so far. And those of us on the podcast team just thought that it would be great to actually hear some of your motivations and your approach to science and maybe how this podcast is shaped a little bit about what you like and how you conduct science in the field.
All right.
Well, listeners of the podcast will know just how deeply you understand and care about such a wide variety of topics. This has come up, in episode after episode, whether it's MRI physics or layer functional MRI or clinical applications. And you've also literally written the book on fMRI. So in some ways, you're the OHBM stereotype with all of these interests, the prototype of an OHBM member. But I'll ask the question that you usually ask your guests when they first come on the show. How did you get started?
Yeah. So if you go way back, I've always been. I think that's talking with my parents, specifically my dad was. He was a teacher, taught psychology. He'd always have dinner table conversations about the brain and how we don't know anything about it, how it's really mysterious. And that kind of piqued my interest a little bit. And I was always interested in the brain, but I also had an interest in other, the hard sciences like physics and engineering. Also in high school, there was a sort of a, I don't know, I would almost say a defining moment when I was looking through I think it was late high school or mid high school. I was looking through a Scientific American, and it was all about the brain. And it showed some of those first like xenon CT or PET images of the brain at work, either language or reading. And that just totally fascinated me. And just to be able to peer into this process of what makes us human, the workings of ourselves. And so then I was intrigued by that. But then, in college, I was thinking of going into medical school, but I majored in physics and thought I would I thought I was sort of hedging my bets a little bit, trying to do physics, but then interested in applications or the brain in some way. Finally, in graduate school, I was in a graduate program in biophysics. I was immediately trying to find a thesis project using MRI to look for some signature of brain function, because typically when I got into graduate school in 1989, you looked at MRI, you couldn't tell the difference between whether that was a living person or a dead person. And there were some hints that maybe spectroscopy might work, or what was called chemical shift imaging. Early on, Levi Hahn came out with his intervoxel incoherent motion, which was kind of exciting, thinking that maybe changes in diffusion might look like perfusion. And so I was trying to do that. I teamed up with I think probably the most important person in my career was Eric Wong, and I teamed up with him. He was already working on things that were involving high-speed imaging like echoplanar imaging. None of the scanners had echoplanar imaging, so he programmed it up from scratch. We built from scratch a local head gradient coil so that we could actually do echoplanar imaging, drive the gradients that fast. And we got some first hints of results from the NGH group in this meeting in San Francisco in 1991, and immediately came back and replicated the results pretty quickly within a month. And since then, wow. I not only found a thesis project, but it sort of defined my career, which I've always feel like I was kind of lucky to be in the right place at the right time to sort of merge these, my interest in physics and also MRI, and then understanding the brain. So that's kind of the abbreviated version of my history.
Yeah, it's a great story. And we heard a little bit about it in a previous episode earlier this season. But you're saying, so you actually came into the field wanting to set up basically functional MRI. So that was one of your goals from the outset before fMRI even existed then.
Yeah. And it's kind of strange. I mean, it's sort of a strange thing how that works. When I came in, I really wanted to look at brain function. And the main tool in my department was this MR scanner. And I was trying to figure out, any way possible of looking at human brain function, whatever it might be. And so that was my goal. I was having a hard time, actually. I mean, certainly, as a first and second year graduate student, having that sort of goal, everyone else had these projects and they were trying to plug me into various things, which was fine. But I was struggling because I didn't quite have a project. And then finally, this came along, and it was a little bit of serendipity. And there was at some point, when echoplanar was possible, I thought, well, maybe it would be great if we could actually image brain function. I wasn't even thinking necessarily along these lines, but imaging brain function along the lines along the temporal resolution at which you can collect echoplanar images one after the other. And I was thinking, somehow there must be some signature in that, because nobody in the field actually thought that much about making movies other than like cardiac or things like that. But and so nobody actually really tried that hard. I mean, there were a number of people like, as we talked about in other podcasts, Bob Turner, Ravi Menon, who were looking at the time course of things, but not many. And it was kind of wide open. And it was one of those serendipitous things that probably could have been discovered maybe 5-10 years before, but nobody really looked hard. susceptibility contrast is pretty robust, and bold luckily just worked. And so it was a little bit of serendipity. I kind of felt that there was I felt pretty strongly. I remember even telling people before fMRI began that echoplanar was maybe has some potential of doing that, but it worked out. And yeah.
I love it. I love it that you just came into grad school with the idealism of the young grad student who sees something. It's like, I think this will work. And a few months later, you have fMRI running, and 30 years later, you're still working in fMRI and just improving it in every possible way. What do you see as some of the biggest changes in the field since, that was 30 years ago that your first fMRI paper came out?
Yeah. I thought about this the other day. Just before I get into that, I just want to mention that it was a unique graduate program. Just also, first of all, it was important. So I had two advisors, Jim Hyde and Scott Hinks. And it's important that, some advisors, and we're all limited by this, we have projects that we want to plug into. Jim just sort of said, hey, these are the tools, just do whatever you feel is best, and I'll give advice. And so that was lucky that I was in that situation as well, that I can sort of, try to find things. But anyway, as far as the field of fMRI is concerned, oh God, so I thought about this the other day when I was, writing some chapter or something, and I'm trying to, I was realizing that, in its essence, it hasn't really changed that much. I mean, when we first collected data, we used a scanner. We did echoplanar imaging with bold contrast. Our voxels were a little bit bigger. They're like 3 millimeter size voxels. We did a task. We looked at the signal change, and we came up with ways of pulling out that signal and mapping it. What has changed? So there's been a lot of changes, obviously, is that the field strengths have gone up. What we know about the signal has increased tremendously. I mean, there was, even back then, though, we worried about veins, and that died away. But then now it's creeping back up. As we go to high resolution, it becomes more of an issue. The overall usage of fMRI has, obviously exploded because, and a key thing there is that, unlike other imaging techniques like MEG or other ones, fMRI sort of leveraged the fact that there were so many scanners around anyway. So it just used all those and exploded. It's like, it was as if, we suddenly came along and realized, we could use our cars for, airplanes or something. And then if you just did one minor tweak, and then suddenly everyone has airplanes. It was kind of like that. So with the scanner, you could suddenly do fMRI with all these scanners. So the field exploded with usage. So that changed a lot. But then there's been a lot of, breakthroughs. Resting state was huge coming along. 1995 brought Biswell, found that. It took about 10 years for the field to fully embrace it. But I think the main thing that's really changed is the level of sophistication of our analyses. So still, most people use bold contrast still. There might be better ways of getting higher resolution, multiband and, things like that. But the level of analysis, though, is much more sophisticated. The level of pre-processing, now we're doing, all types of, pattern effect mapping, various types of dimensionality reduction techniques. The questions are becoming more sophisticated. All the network analysis of fMRI is sort of taken off, and it's not clear how far it will go, but right now it's really taking off. Another thing that hasn't changed that much, though, is that, the clinical applications are there a little bit, but we're still trying to make more inroads for clinical applications. So that's kind of, in a nutshell, how it's evolved. I mean, certainly it's taken over. It's become a believed tool and a useful tool for most cognitive neuroscientists. Mm-hmm. It's now like, it's the backbone of most of what OHBM does. I mean, certainly other techniques are growing, and I hope they do even more so. But still, fMRI with bold contrast is what we do for the most part. So, yeah.
Yeah. Great. Yeah, it's awesome to hear your perspective on what's happened basically since the beginning, and since you're still you're still at the forefront of all of this. What do you see? Like you've talked about so many of these analysis approaches. What do you see as being the next challenge that you think that fMRI will be able to tackle and overcome over the next 10 years or so?
That's a good question. Certainly there'll be so the big, there's certain things I'm sort of excited about. I think that there's still more information in the time series than we've been able to robustly extract.
Mm-hmm.
I think we can also get rid of more of the artifacts, like the respiration effects and things like that. I think we can get rid of. I think that we're just really beginning to look carefully at the network properties derived from using network analysis with time series fMRI. I think that that has a lot of work to go. Incorporating that into models and that to make more insights. I do think actually the big elephant in the room is the clinical applications, and that's a huge challenge. And the big challenge is simply that as robust as fMRI is for looking at brain function, the effect size is relatively small, and the variability from subject to subject is somewhat large. And so to get any sort of meaningful biomarkers, you need a lot of data. And then the question is still out. Let's say you do get biomarkers. Can you really use those, put a subject in the scanner and say, oh, you're a member of this distribution or not with one subject? That's still an open question.
Yeah, right. When will we feel confident that we're making the right assessment there?
Yeah, but also I think that another clinical application that's kind of a low-hanging fruit is once neuromodulation gets more popular, like using TMS in a very focused way for disease, it shows a lot of promise. You definitely need fMRI to just show where the landmarks would be and where the areas would be to guide TMS. So that's a huge clinical application that's waiting. I think a few people are working on that already, obviously. But yeah, the big challenges would be to have a little bit more, layer fMRI is near and dear to my heart, and doing whole brain layer fMRI in which you could actually interpret the results, having, input and output at specific areas and showing that will kind of rewrite the landscape in many ways and what fMRI could do, how deeply it can address these questions of neural circuitry. So has potential. A lot of work that needs to be done to really get that properly working. Right now, we have about 5 people working on layer fMRI, and we're all struggling like crazy, just with the analysis pipelines, just to make sense of what we see. So that has a lot of work to be done. It's very different than the early days where you saw a blob and that was great. It's so.
Yeah. So how did the transition come for you, or when did you start getting interested in the laminar potential for fMRI, or I guess depth-dependent fMRI?
Yeah. Well, I've always been interested. I mean, part of what I do, I'm lucky at the NIH where I can sort of straddle, be right at the methods, the limits. So I've always tried to push the temporal resolution, how deeply we can interpret the functional MRI signal in terms of temporal resolution. And also, I've always been trying to push the spatial resolution. And I became more interested, honestly, I think much of my research is driven by the postdocs that I choose. I sort of have something in mind, which I think is interesting. And then I put out an application, a job opening for postdocs, and then I find them. And then I usually try to sort of triangulate between what their interests are and what mine are. And, that's what happened earlier with Nico Krageskorde. He was a postdoc of mine, very interested in pattern effect mapping. I became suddenly, amazingly interested in that. And so he just took off with that. And that was really great. And for layer fMRI, I believe it was, already maybe 5 years ago. Time is sort of distorted by COVID, but I think, around 2017 or no, longer than that. When I saw Renzo give a talk showing some early work on layer fMRI in the motor cortex, he was working with Bob Turner at the time at Max Planck. And I'm like, he's great. I'm going to try to recruit him. And I was able to recruit him to my group. And then it took off with Renzo. I just gave him complete room to work and develop things and try things, and kept on, my style with postdocs is I let them go, and then I, give feedback and point in different directions here and there. But that's when it took off, and Renzo's was amazing. And I think it's still, sometimes we have dead ends. I mean, sometimes there are dead ends in other areas, like trying to push the temporal resolution got kind of difficult. And I still think there's still work to be done there, but layer fMRI, I have no reason to believe that it won't work in many, many more places, in many more contexts. So that's when it got started, I guess, somewhere in the late teens of 2017 or something like that. Yeah.
That's awesome. Yeah, that you can be so inspired by the earlier career scientists that are coming through your group. And that hints at actually the next question I wanted to ask was about how you, after and with such a fruitful career so far going forward, how do you get inspired for new questions? And I think part of it is what you've just described of inviting people to your lab who are doing exciting things and working with them, triangulating to form some new scientific questions. But do you take any other sort of like top-down approach to how you formulate your next scientific questions? Do you have any sort of grand approach like that, or do you just go where the science takes you?
That's a little bit of both. I mean, you almost have to do both because most questions. I mean, I firmly believe that. I think that I firmly believe that the leverage of your work depends very much on how well formed your questions are, and my question, I usually look at the entire field. Like whenever I'm reading a paper, or even listening to a talk, I usually am not taking notes about the talk or the paper unless they have a reference for a paper to read or something like that. I'm usually writing down what occurs to me as an idea when I'm listening to the talk or reading the paper. And that usually, they open up ideas of things to try. Like if I hear, like for instance, like many people, like Yuri Asan, for instance, an example. I remember listening to one of his talks early on of doing cross-subject correlation. And suddenly I see that and I'm like, that's a great idea. There's so many things that could be used using that to ask different types of questions. So what I think that I have a kind of maybe a skill, and I always try to keep on growing it, is trying to take what exists and trying to sort of keep on expanding, my awareness, at least, of other work, of other questions, so that I'm trying to, fit the methods in with the questions and ask the more meaningful questions. So it's so easy to fall into a rut, like, especially if you're a methods person. And this is what I always talk to my group about, is that it's so easy to ask a methods question, like, oh, how can we maybe do that a little better? And those are certainly legitimate questions, but really, and this is why, and really the question should be more along the line of, how can we do something, totally different? How can we ask a very different question using, some twist on a technique that we can take it further? So I usually try to make sure they don't lose the forest for the trees. And so, once again, there's a place for like incremental development, which I think is important. But at the same time, I think it's always important to think of ways you could, use methods in different ways or try something totally different with them.
Right.
Yeah. So I guess that's sort of summary. I don't know if I really hit on the head exactly what I do, but I'm always just trying to, put things together and try to, I'm always pushing myself to ask, what would be the question that how far can this technique go? Things like that. So, yeah.
That's awesome to hear. Yeah, it's just such a critical piece to just keep on looking for the new application, looking for, how we can push things a little bit more and what that opens up. That's great. So I wanted to ask a little bit about the podcast. I hinted at this a little bit earlier, but you've been running this podcast for say over a year. You had some previous podcast experience too. Has there been any way through the conversations you've had through this podcast, has your outlook on science changed at all? Your outlook on the field, on what's important in the field? Has anything shifted for you, like as a result of running this podcast and talking to so many new people and old friends?
Yeah. I like to say that, it's certainly, it's been, it's way more work than I expected it to be. And, because every week or two, I have to do my homework on the person. Sometimes it's super easy, just because it's part of, it's what I know. But other times it's really hard to get up to speed enough to feel like you can ask meaningful questions. And I think that, and that's actually part of the reason why I did the podcast. One of the reasons why I want to do the podcast, not only because I really enjoy asking questions, I enjoy engaging people, and having a back and forth. It comes to me naturally. I really like doing it. Maybe I'm still not that good at it, but I like to think I'm improving. But I do. What has really helped me is it really has. I mean, everyone has their list of papers that they want to read, and there's something about having a podcast deadline after 2 weeks on someone that forces you to just study their papers in a way that you wouldn't otherwise, and really get kind of on top of the field and kind of and that aspect of things to sort of be able to ask the right questions. And I think it's, personally, I think it's helped my own science because suddenly, 1 week clinical applications will become, this sharpened the focus will sharpen, the breath, it's like a camera, it's like the breath will increase and you'll kind of have a good sense of what is the state of clinical applications, what's the state of network neuroscience, what's the state of all kinds of things like that, the replication problem and whatever. And I think that's helped me a lot. I also have I just read the other day, and it was really a good insight, is that one thing unique about conversation is that, usually when you're only thinking on your own, your thoughts kind of are transient and they don't really get ratcheted forward that much. When you're just thinking about things on your own, you can think about them unless you really are disciplined. Conversation's unique in humans is that, we're focused on a thought or a set of thoughts or ideas, and we're going back and forth, for however long it is, an hour, and we're really making progress in keeping our thoughts focused on the issue and going forward. So I think that's really powerful. I would recommend even, it's helped me, but I think in general, having conversations with other people about ideas is way more helpful, I think, than just, certainly there's a place for thinking on your own, but having conversations is very, very, it's focusing and it keeps you focused on something for a longer period of time than you would otherwise. So it's useful. So, yeah.
Yeah, a lot of the fun. That's a lot of the fun of conferences and just meeting new people and talking about the science, figuring out some way that what they do. You didn't think it would apply to your research at all, but suddenly making that connection and building into something even bigger.
Yeah, and you realize everyone's struggling. We're all, even the people who are absolutely on the top of the field who write these beautiful papers, we're still struggling with, the limits of what we can do, the limits of what we might try, the questions. Everyone's at that edge, and the people who can actually dance at that edge, the best are the ones who are successful. So,
Yeah.
Yeah.
Good perspective. All right. Well, we have something a little bit special for you, since you've been the host of this podcast since the beginning. And you also have a long history working with a bunch of great people and some great trainees. So we actually, the podcast team, put out some feelers to some of your other colleagues and trainees, and we were soliciting some questions. We thought, hey, what would they like to ask Peter? With a little bit of distance in time or space, and I think we'll see a little bit of personality come out here, and maybe we'll have to do a little bit of editing for some of these questions, but I'm really looking forward. So I'll ask you a few questions. I'll give you some space between each one. I won't tell you who asked each of these questions, who submitted these. So maybe a part of your answer can be guessing.
Try to guess. Okay.
Who submitted it? All right. The first one we'll start with. When your life flashed before your eyes, as it may have in a tidal cave on the Nepali coast on Kauai, what did you think about? Family, science, the afterlife?
Oh, that's great. That's awesome. Yeah. Well, just to give it a little context, yeah, I was, there's one of my favorite places on the planet is Kalalau Beach on the Nepali coast of Kauai. And I was there with my fiance at the time. And yeah, she was, we were trying to find a cave, and we were kind of walking along the coast, and we got sucked out, almost sucked out to sea, and she can't swim. And, it's interesting. That is the closest I think I've come, maybe, I think, to dying, I guess. And what's interesting is that it was there's a secondary question related to that, and that is, I somehow managed to get hold of a rock. I'm being pulled out, but I barely got hold of a rock. So I was realizing I could kind of save myself. And then my fiance, though, was kind of out there, a few meters, being pulled out.
Yeah, wow.
And then, but the really interesting point was, do I let go of this rock and and try to save her? Because if I don't, she's going. Or do I hold on to save myself? And that thought occurred to me, but it quickly, then an impulse was to save her, and you just do it.
Mm-hmm.
But I held on to it long enough to know that, this is what I'm doing. I'm giving up my safety to save my fiance. And yeah, it was intense. It was very intense. And yeah, I managed to get out there, and she managed to hold on to me. And then at that point, it was just, you weren't thinking that much. You were just doing whatever it takes to get back to shore. And it took us about 45 minutes. I eventually was able to get beyond the riptide and kind of move back, but it was touch and go for a little while. And it's funny because we even tried, jokingly afterwards when we were back, we tried to simulate the thing, having her hold on to me and me swim, and
Mm-hmm.
I could barely do it for 3 minutes, and somehow I did it for 45 minutes. When she when she was holding on to me. But yeah, that's perspective building, and not much really. That the key thing was the moment in which I let go of the rock to go after her was stood out in my head. The rest was just a blur of just trying to survive, and so I didn't really think of much else. But yeah.
Wow. That's incredible.
Yeah.
Do you have any guesses as to who may have asked you this question? maybe an old colleague, old friend?
Oh man, who could have asked that? I mean, I don't even, I forgot who I even told that story. I told it to a number of people. Yeah, I don't know. I can't.
I can give you a hint here. It's somebody who has been on the podcast.
Oh,
maybe even multiple times.
Was it? I guess that would narrow it down pretty much. Was it Ravi Menon, or was it? No.
Yes.
Okay.
Yeah. That was Ravi Menon submitted that question.
Yeah, Ravi and I both love Hawaii. He's actually, I think he grew up some of his time in Hawaii. So, okay. Yeah. We talk about the riptide. It's dangerous. I mean, it really is, and you don't realize it. You're walking along, and it's funny. We were just kind of walking along. The water was up to our neck, and we're like, "Oh, we're just going to get around this cliff," and then it picked us up and pulled us out. So, okay, good, Ravi. All right.
Well, yeah, he's giving us all a little bit of extra insight into Peter Bandettini now. So, thank you, Ravi. Okay, we'll move on to this next question, which, depending which direction it goes, may need some editing, but I think it'll be good too.
All right, this is great.
So the question is, what is the closest you've gotten to getting arrested when interviewing a postdoc?
That was Kevin Murphy, right?
There we go. Yeah, that's fortunately only once. Yeah, there's only one that stands out there.
That was awesome. That was great. So the NIH is a very strict, sort of a strict place. We have our campus, and we have our. I think that was right after, after 9/11, security was pretty high. They have their rules, and it's a dry campus. There's no alcohol on a campus, and Kevin being coming from Ireland, it's sort of a customary thing to bring some scotch or whiskey or whatever he was bringing, and it was normal. And so he was trying to bring it in on his first go, and security stopped him, and he's like, "Oh, well, okay, I guess I'll do whatever." And I think I intercepted them at some point and said, "Oh, why don't you just come in the side doors here?" And, I was thinking nothing that much of it. And he came in the side doors, and apparently security saw him do all this. And somehow while I was literally talking to him in my office, I get a call, and they basically said, is Kevin Murphy in your office? And I'm like, yeah. And like, okay, well, we'll be down. And I'm like, well, what is this about? It's like, oh, well, they brought something in. And I think I remember with the secretary at the time, we quickly, we're like, oh, okay. So quickly I jumped out of my office and said, security's coming, let's hide the alcohol. And so we found it. We found a place to hide it, and they came down.
Number one, do the important things first.
Save the alcohol. Now, they came down, and they warned. They didn't do anything. I mean, they didn't actually do anything, and they didn't search for the alcohol or confiscate it. They basically said, "Well, it's very serious. You shouldn't do this." And we were very apologetic, and we understood. I mean, it's not like we're going to suddenly, throw a party or something. But so they understood the context, and that's the thing with this. Yeah. It's funny now that I've been there for a number of years, it would be less, I would just kind of like automatically say, oh, well, we'll get it some other day, or that's okay. Just, but then I don't know. I just probably wasn't the best decision on my part either, but it was great, because then, Kevin has this story to, we all remember Kevin as far as when he started out, and that was good. And I got to know the police officer, and everything turned out okay. So.
And yeah, of course, we should note that it was a successful postdoc interview also.
Yes, it was. Kevin was awesome. Kevin is awesome. And he did a lot of great things, and was one of those people who just kind of came in and didn't have anything specific planned, but he actually really cranked in certain things. I mean, specifically, a number of things, but one of them was writing kind of the definitive paper on whether to do global regression or not. And that was Kevin's paper. He did other things too. And he has a nice paper thinking very clearly about how long to scan based on signal to noise and whatever. And now he's really getting into the physiology and he's doing a great job. So yeah, I really like Kevin. Kevin keeps me honest too. His Irish wit always knocks me down a few notches, which is always good.
All right, that's awesome. That's such a cool story. Pretty unique story for you.
Yeah.
Great to hear. Okay, so we have, I think, 2 more questions here. So this one might be a little tougher to guess, but I'll let you guess too. But the question is a little bit more broadly, what do you think is the right balance between staying on top of the literature in your own ever-changing subfield versus keeping up with new ideas from broader realms in neuroscience or psychology or other related fields? And does that balance change over the course of your career? I guess, has it? And do you think it should?
Yeah. So I feel like I don't even know if the word balance is the right word in some sense. It's sort of like along the lines of, you have this meta balance of constantly going between not lack of equilibrium, but sort of, so I think the idea is in sort of the analogy would be maybe, they purposely designed like fighter planes to be unstable so that they are more adaptable in some sense. And I think that I think on one level, you definitely need to know your domain deeply. And so you need to do your best to sort of keep up on the literature, at least the relevant literature. It's hard to know what the relevant literature is, but to sort of keep reading it and keep thinking and keep looking and reading the latest papers. That said, without a doubt, you'll have more ideas come to you and more flexibility if you do purposely try to, read outside your field. A great example is someone like Ravi, actually, now that I'm thinking of him, is that, he's a physicist, but, he regularly goes to SFN and he purposely tries to learn things that he knows nothing about. And sometimes it helps. It always helps in some way, but sometimes it really adds to certain ideas. And there's certain things like I was just reading another paper, just skimming it the other day, of resting state fMRI. I mean, spontaneous activity in the brain has been known for long before resting fMRI began. And just understanding kind of what they observed can lend insight, or even things like, if I'm just looking at the signal and reading about fMRI and things like that, I wouldn't really appreciate that, the interesting interaction between inhibition and excitation, adaptation, and things like that signal still might be in the fMRI signal. Reading those papers sort of primes me to sort of think, oh, how can I maybe pull that out? So yeah, definitely balance is good. I would say it's important to know deeply, to go down the first principles as much as you can in your domain, and then try to draw connections with and purposely learn other areas. It's hard. Yeah. And it's sort of, you set yourself up to look sort of naive. And, when I talk deeply to neuroscientists, I'm naive, but I think also that as a methodologist, I can help them more, because sometimes they're thinking very specifically about a problem, but they're not really thinking about how to use fMRI to answer that problem, because they don't really know what the nuances are. And so talking to those people a lot, I think, is really useful, not only for myself, but for them as well. So yeah. And yeah, like for instance, Renzo Huber, when he came to my group, I forced him to, well, I didn't really force him. I mean, I didn't really have to force him to do anything, but I encouraged him strongly to go to SFN. If you're going to do layer fMRI, you better get familiar with that whole ecosystem that's been around for years. And so,
right.
And he did that, and that was great. So
yeah, it makes it so much more impactful when you know the actual biological principles that you're recording, and it can really help validate what you're actually finding. And I'm guessing it drove some directions for him and for your group also to have that sort of information.
Yeah, it really has. Yeah, and there's even things that, right, and also we're sort of more aware. We're not just blindly saying, oh, that layer fMRI will just work. I mean, there's a lot of very, very good neuroscientists who say, well, you can't quite resolve layer 5, and that's important because of this. And so you have to sort of step back and think, how deeply can we interpret this signal? And that helps, refine your thinking on that as far as that's concerned. So, yeah, I can't guess who asked that question, because I think, it's a general question. It's hard to know exactly who would be asking that.
yeah. There's a follow-up. I don't know if it'll have many more hints, but the follow-up is, so how do you determine whether something like a new acquisition method or an analysis method or a new theory, how do you determine if it's something that has real staying power or if it's just a passing trend? Is that something that you're able to discern, or do you just go with it and find where it leads and change course if it doesn't work out?
Yeah, that's a really hard one. And I do this all the time when I'm looking at, my postdoc's
Right.
data. I'm trying to look at it and think, oh, is this worth going further with? Is this, and I think that from the experience of looking at I think you always have to look at your data, and I think you get even beyond the statistics, you kind of get a sense of whether things look good, like they look like they're fruitful, based on how noisy things are, or how repeatable they are. Even with your N of like 5 or something, you get a sense of how much things might work. Like there's a couple of other layer fMRI techniques, and they look good, but they don't quite look as good as Vaso looks. Vaso is and it's like I'm still like they want I know they want me to say, hey, this is great, this is the same as Vaso, it might be better, and I can't say that because I haven't quite seen the true comparison to show like the sense of higher signal to noise. And I it's funny because usually those should be statistical questions that should just be obvious, but I feel like it's not. I actually think that you kind of have to tons of experiences looking at the data and getting a sense of whether this is something that's pursuable. What I tend to do a lot, I mean, I'm sort of known in some sense. I usually like to throw out sort of kind of crazy ideas to just try things. I'm very much of an empiricist in that sense. I'm like, oh, what? One of my favorite lines from my colleague Eric Wan was, let's just try it. It's so easy to try things. You should just try things. So many people talk themselves out of trying things before they even try it. And they usually get so much more information just trying it once or twice and seeing what might work. And so I'm all for that. And I'm all for like looking carefully at the data and going from there. Regarding bigger things, the latest example is, we already talked about layer fMRI. That's hopeful. And I feel like that's very hopeful. It gives good preliminary results, but it's still not clear to me. I'm not 100% convinced it's gonna pan out, but I think it will. It just might take a little bit more time than what people anticipate. Even general time series analysis, I think that's there's work there that I you look at the progress that's being made and you feel like this is robust, and there's a lot more that could be done with this. And but there's other things too. There's other pulse sequences, there's other processing methods that at some point you're just like, well, this may not be the most fruitful thing, and you go from there. And so you try to, and it just kind of dies away. But I don't know. I don't have any clear heuristics for doing that, other than just a lot of conversations, a lot of experience, a lot of looking at data, a lot of looking at the raw data, and going from there.
Yeah. I'll let you take a guess if you think, if you have any ideas who this could be. And a hint, it's one of your former postdocs.
Okay. One of my former postdocs.
She's now at an Ivy League college.
Oh, is that Emily?
Yeah, that was from Emily Finn at Dartmouth. Yes.
Yeah. Yeah, no, she's right. I mean, that's a perfect example with her. I mean, she's doing this. It's funny. There's an example of what she's doing. She's doing naturalistic stimuli. So why would anyone think that naturalistic stimuli and cross-subject correlation, looking at individuals, is going to work? And it just, it's clear that when you make these matrices of cross-subject correlations, that there's tons of information there. It's not noise. So I and she was already going in that direction anyway, and I've always encouraged her to do that. And she's another one of those postdocs who kind of comes in and just, you sort of step back and let her go, and she just cranks.
Yeah.
And she actually does, and she had a very, she did the same thing. Like, for instance, she's now convinced that pure resting state is less powerful than being driven by like naturalistic stimuli. And that's a real decision. And that's sort of based on not any one paper, or it's just based on a sense that she wrote a paper actually quantifying it afterwards, but she had a feeling after working with resting state that this might be a better way in many different ways. And so that's an example of that. So,
yeah. All right. So we have one more question, and this one will be a little different. So give me a second. I think I gotta share my screen. We actually have the audio of this one.
Oh, great.
So I think you'll probably be able to guess pretty quickly who this one is from.
Okay.
Peter, while I was working in your section, I remembered that there was this one reoccurring theme and suggestion from you in our group meetings regarding the presentation of our research. You always said, quote, "It needs to be extremely clear," unquote, with emphasis on extremely clear. In fact, I can still hear your voice in my head sometimes saying this whenever I'm writing a paper or preparing a talk. Ironically, despite your love for clear science communication, you are researching the most complicated human organ, the brain, with an immensely versatile tool, fMRI. So please share with us your secret of clear science communication. So no matter if it's about books or papers or blog posts or podcasts, you've obviously figured it out. So what's the recipe for explaining complicated things clearly?
Oh, that's awesome. That's awesome. Yeah, Renzo. Yeah.
Yeah, it's come up a few times already, but I just thought that was such a great question. Just tackling, all of this, all the science of it, the communication of it. Yeah. So how do you wrap up all of these multiple scales and still somehow get around to communicating these incredibly complex questions just in such a clear way?
Yeah, that's a really, that's a really good question. I've always had, and everyone has their blind spots, and I don't think of myself necessarily as having figured it out. Unlike in spite of what Renzo says, I'm still working at it all the time. And it's not only a question of being clear. One can be very clear, but it's also pitching it in the right way to the audience that's most resonant. If I'm talking to a group of high school students, I can be very clear, but they wouldn't care or know what I'm saying. So it's sort of kind of getting in the heads of the audience. And I usually, when I write or when I talk, I try to anticipate who's listening, and I try to really put myself in their position. And that helps me a lot in terms of not using, I've always was told early on, never use jargon words. I even hate abbreviations. I even stop even my people people who talk to me at the NIH when they start using acronyms. I'm like, what does that mean? What is it? You have to clarify everything. And I usually just base it on my own. Like if I'm reading a paper or listening to talk, I'm like, I don't really know what he's saying there. And a lot of people sort of are more tolerant of that. They kind of go along and they say, well, I don't really know what he's saying. And I'm kind of getting a few parts. But I get kind of upset by that. When I listen to talks where I don't, and this is maybe where the only place where I express that is when my postdocs give talk at lab meetings. So I stop them and I say, well, what's the context? What you have to start out, you have to lead people by the hand and say, everyone's smart, but I mean, nobody should have to work that hard to know, what you're doing. And it even helps the person know what they're doing more. If they can actually sit back and do like an elevator pitch, and put it in a context that is digestible, and then that forces them to refine their thoughts and clarify their thoughts. So it's important not only for communicating, but important to think as well. Kind of an example, I was thinking about this the other day, and an example in my mind came to me is that a lot of people's work is really impressive. It's kind of like it's like a Rube Goldberg machine. If you ever heard of those, they're like, very detailed, complicated. They're all over the place. And nobody know, you don't really get like a gist of what it's all about. But then the other extreme, which is at least as complicated as a Rube Goldberg machine, is like a Tesla car. It's super elegant, or like an Apple computer or something like that. Super simple, but it's really well thought out. And the experience of it is, it's like, it's basically like the ideas were refined, and there's extra iterations of actually making it really work. Unlike a really complicated Rube Goldberg machine, which is, impressive, but it's like you don't really get of where it's going or what it's doing, or what the principles are for which it works. So, and so the way I guess boiling it down, I basically, I'd like to think that when I'm listening to talks, I like to just think of, I like to put myself in a position of, the first year graduate student, or even somebody who just, doesn't know the field and is trying to understand the point of this and what the thought processes are. And it doesn't have to be that complicated. I mean, most of your best science papers or Nature Neuroscience or whatever, are pretty elegant, simple ideas that it takes work to sort of chisel that down into like, this is the essence of what we're talking about. And then of course the details can be filled in, but as long as you have that framework, like what are we actually trying to do? What's the principle? Then it helps people think more clearly about it. So I put myself in a position where I'm purposely, kind of ruthlessly trying to make it simple, keep the purpose in mind, refine the objective, and also the strategies, and keep as close to, first principles, as opposed to getting bogged down in the details. Because a lot of talks start out, or even papers start out, just throwing tons of jargon out there, and you don't even know what's this paper about, what's this talk about, and that's tempting, and everyone does it. But I think it's important to get the discipline of actually communicating to someone who doesn't know, which helps refine it. So yeah, I'm constantly working at that myself. So
yeah, but again, it's one of those things that just, the act of working on it is just so beneficial. And you're right, it does take extra effort on behalf of the actual person presenting or writing, but just that little bit of extra time thinking about how to boil it down, like you're saying, how to really chisel away and get to the heart of the matter, just helps everybody and really gets across the message, right?
Yes.
So it's the presenter's, responsibility and kindness and job to really get to the heart of it and make other people see why it's important to them or just to the field. Yeah,
I totally agree. And every once in a while, right, I have to give talks to like high school kids. And, one time I gave a talk to, my parents are in a retirement home. So all these people who are, 80 and up, it's a very different audience. They're all well-educated and very smart, but they're older and they're not aware of the field. And so you have to try to get in their heads and how they're thinking, what's relevant to them. It's important, it's having some empathy, intellectual empathy in some sense. And that, not only that, after giving that talk, I have some additional insights of my own, that I can bring to my work. And that process of doing that is a worthy thing to do, as much as possible.
Yeah, that's great. All right, so we can, I guess, start to wrap it up here. But as we've heard, first off, just want to thank all of our people who submitted questions. We want to thank Ravi Menon and Kevin Murphy and Emily Finn and Renzo Huber for their very insightful questions.
Yeah, they were great.
We learned a lot about Peter and about how he approaches science here. But you've clearly had a tremendous impact on the field and on individuals, on trainees throughout your career, people who have come through your lab and others in the field who have just seen your talks or interacted with you at conferences. So I guess after 30 years of this, do you have any advice for younger or earlier stage researchers? This is a question that you often pose to your interviewees, so I'm flipping it around on you.
Yeah.
What advice do you have for early stage researchers?
Yeah, that's hard. I mean, it's easy to be kind of cliche and sort of say all the standard things, but as far as thinking of helpful advice that I think helpful given to people, a key thing is to always make sure you're not losing the forest for the trees, because it's such a complicated field that it's so easy to get sucked into these like issues of details, which are all important, but it's important to always pull it back, and to be able to pull back, you have to purposely read outside your comfort zone and listen to talks outside your comfort zone. Another piece of advice I would give people is, like, early in their career, is that life is kind of malleable. I mean, it really is, and I think that there's a lot more opportunity for trying things or talking to people or taking on new initiatives than people realize. It's all over the place, and the people who are successful are the ones who realize that and make the most of it. So I think that's another thing. And also, early in my career, I never, and this might be good advice, it might be bad advice, but it worked for me. And this, people say different things now, and now I do it differently slightly, but I literally said yes to everything.
Wow.
People, early on, they asked me to give a talk. I'm like, yeah, sure, I'll give a talk. And they asked me to help out with OHBM program committee. Somebody, at some point, I was still a graduate student. My advisor could probably say, oh, you don't have time for that stuff. I'm like, yeah, let's do it. And all those things really kind of, I mean, when you're young, I think you should be doing that. And as much as you can. You don't typically have other demands and things like that. And one person once told me, doing a postdoc is like academic nirvana. You don't have to worry about funding. You don't have to worry about all these other things that are burdened. If you're a postdoc, and you should be just trying as many different things as possible, and just taking on, as many things as possible. Even book chapters. I mean, I wrote a bunch of book chapters when I was in graduate school, which is kind of, many would argue, and probably correctly, is a waste of time. But at the same time, I think it also has helped me then write papers using just the act of writing. And this is like anything. Like taking on book chapters is not just for the chapter; it's to take on a challenge of writing that's somehow meaningful. Yeah. And that's the same with the podcast. It's like some people might say, oh, this is a waste of your time. It's definitely not a waste of my time. So, hopefully it's helpful and entertaining, but also it helps me get ideas or refine my ability to talk to people. And yeah, I think that there's benefit that could be reaped from saying yes. Of course, you can get into trouble. If I say yes to too many things, then some things fall off, and I'm not as good at getting everything done. So you have to be smart about it eventually. So that's pretty much it. And also another key thing, as I mentioned before, don't talk yourself out of trying new ideas. Don't be afraid of being wrong. Don't be afraid of just try things and put yourself out there and try ideas and talk to people and ask questions. that's so fundamental, and it's an important exercise. It's like a discipline to, it's like brushing your teeth. It's like there's things that you just should do as much as possible, and that's one of them as well.
Yeah, that's great advice. Well, Peter, I don't know if you have any last words you'd like to. I think you'll probably have a few more chances to talk to people on this podcast. I have a feeling we'll have a few more episodes coming up here. But if there's anything else,
no, other than I think you did a great job. I think you're a natural at interviewing.
Too kind. I've listened to about 40 of these, so I'm just trying to pick up from where you lead us. So,
all right. Well, one other thing I just want to say is that you'll give me ideas in terms of how to. I'll have to start asking other people about. I like it's like, this is your life sort of questions from other people asking them. So that's great. But yeah, I appreciate it, and thanks again, Kevin, and look forward to doing many more podcasts. So, all right.
Well, thank you so much.
Neurosalience is brought to you by the Organisation for Human Brain Mapping. This week's episode was produced by Rachel Stickland and Kevin Citek.